Thank you very much for the introduction. Yeah, feel free to take a seat. Okay, yeah. Hi everyone. Good afternoon. Thanks very much for coming to this session. My name is Chi. I'm a principal researcher from Microsoft Research. I'm based in Redmond, so it's good to come here. Actually, this is the first time I ever gave a talk about AutoGen in the Bay Area. So I'm very happy to kind of talk to the audience here. And introduce this open source project called AutoGen as a programming framework for Agentic AI. So before I start, I want to do a quick poll. How many of you have heard of AutoGen? Would you put the hands up? Oh, that's awesome. Yeah, thank you so much. And how many of you have tried or used AutoGen? Okay, also quite good. Yeah, thank you so much. Happy to see Bay Area people here using AutoGen. So in that case, I will maybe briefly talk about maybe the background of the AutoGen, of the Agentic AI, and some key concepts of this framework. And I will show you some interesting use cases, and finally talk about some of the roadmap. And I think this conference has a big focus in around of the evaluation. I will cover some of the use case that evaluation part as well. All right, let's get started. So first of all, let me begin with the motivating questions, why we built this framework. It's mainly motivated by two big questions. One of them is, what are the future AI applications like? Apparently, this is driven by the power of the new language models and other AI foundation models. And another one is, how do we empower other developers to easily build them? So along the way, we have made a series of technical bets. Our first bet is that the future AI application we think is agentic. And we had that bet very early last year, around the time when GPT-4 was released. And not only that, we also think the agent, if we make multiple agents that can connect the different kind of entities like language models and tools and human inputs, it can maximize the power of the language models and make the application really useful. So multi-agent interaction can really unlock new levels of capabilities. So last year, we have been building this AutoGen framework as the programming framework for building next generation of language model applications. And especially using the multi-agent conversation as a central mechanism to connect all of them. It's a joint work with my colleagues and also our collaborators from academia like Penn State University and University of Washington. So we have been building AutoGen as a programming framework for Agentic AI, just like PyTorch for learning. Initially, it was developed inside the open source project called SAML. And in last October, we moved it out to a standalone repo on GitHub. And since then, it got took off, and we have added a lot of new features. It's very rich and support many different diverse applications there. In this talk, I will mainly focus on some very essential concepts of AutoGen, because it's impossible to cover all the rich features there. But if you think about this, all the important rich features all boils down to some very basic intuitions. That is, we want developers to build any complex agentic applications in just two simple steps. The step one is to define the agents of different roles, and step two is to get them to talk. Okay, so here there are two important concepts. One is a conversable agent, another is a conversation program. The agent abstraction in AutoGen is very generic. It unifies many different types of entities, including language models, tools, and human inputs. So you can create agents using language models to generate natural language replies, or you can create agents that based on code without using language models, and for example, just do Python program execution. And you can create also agents that can provide human input to other agents. And you could also mix these different kind of backends in the agent, or even combining different agents, multiple agents, make them converse to each other, and eventually wrap them up as a super agent. So we provide very rich kind of conversation patterns, including sequential chats, message chats, hierarchical chats, and group chats, and so on. And those compose, then you can use these building blocks to compose more and more complex and powerful agents recursively. In our technical report, we studied a number of different applications, including solving math problems, doing retrieval augmented question answering, making online decisions, doing supply chain optimization problems using multi-agent coding, solving tasks dynamically in the group chat fashion, or even building games like conversational chats. And these also showcase different kind of conversation patterns. There are some very simple patterns, but you can use this simple building block to compose much more complex workflows. In the next few slides, I will use one example to go through some of the basic ideas. This example is a multi-agent coding example, and it's solving the supply chain optimization problem, which is actually the first production use case of multi-agents. So in this problem, we assume this users of some business manager, for example, want to answer questions about supply chain change. So they want to answer some OTP questions. So if I change my shipping partners, what does that change to my overall cost and so on? So this is a hard question that you can't easily get answers from ChatGPT because it needs access to the user's data and it needs to run some proprietary tools to optimize it and get the result. But using this AutoGen framework, my colleague is quickly able to create 3 agents with different roles as commander, writer, and safeguard. The commander is agent using Python tool. It doesn't use any language model, but it's able to take the user's question and send them to the other agents and coordinate between the other agents and eventually collect the answer back. Writer is an agent based on language model and can write code and have access to some proprietary optimization tools. And safeguard is another language model-based agent that does code review and return whether the code is safe or not. So they will repeat back and forth until the final answer is generated, and the commander will generate that to human user. So from the user perspective, they then don't need to know there are multiple agents running at the backend. They can have the perception that they're dealing with a very powerful, strong agent, and get their question answered in an intuitive way. If we go into this workflow and diagnose how it works, it basically uses the nested chat conversation pattern. So initially, the commander receives a question from the user, and then immediately will initiate a nested chat between itself and the writer agent. So they send the question to the writer and ask the writer to generate code. The writer will generate some modification of Python code snippet to some existing built-in Python tools to solve some optimization problem. So it can make some change according to the question, like change this constraint, and rerun the optimization code. But before the execution, the commander will hold that off because it needs to ensure that the code is safe. So they will create another nested chat between the commander and the safeguard and ask whether the code is safe. The safeguard will return safe or unsafe. If it's safe, the commander will execute that code. Otherwise, it will send it back to the writer and ask to regenerate the code. So in this case, the code successfully runs, and so the commander can send that result back to the writer. If there's a failure in the code, it will send the error message instead. So after all the several iterations of the nested chat finished, the writer eventually generates the natural language answer back, and the commander will return that to the user. So that's how this nested chat can easily enable some intuitive reasoning about these complex workflows and quickly enables developers to build out this workflow. And if you look at the safeguard performance and try to analyze, okay, if we put the functionality of the 2 agents, writer and safeguard, into 1 agent, what happens? So the blue bar and the blue kind of a solid bar represent the multi-agent setup, and the bars with the lines represent the single agent setup. And blue bars is for GPT-4, red bars are for GPT-3.5. We see that the performance of single agent is much worse than multi-agent in this case regarding the safeguard performance. There's a drop about 20% from multi to single setup for GPT-4, and there's an even bigger drop, like 40% for 3.5. So this showcases that if for certain scenarios, it's beneficial to separate the concerns into different agents and make them focus on each area. And especially for the weak model, you need more of this. So that is just one example. There are many more examples, but let me quickly summarize the benefit of multi-agent conversation and AutoGen. So in general, it enables the developers to handle more complex tasks and or improve the response quality. Then the reason of that is you can see the multiple agents can iterate over feedback and have a natural improvement during the process. And it allows the developer to divide and conquer the complex tasks. And sometimes you can create agents that are focusing on guardrail, validation or grounding, and provide some external verification through the RM-based agents. And it's beneficial also to have this generic framework so that we can make it easy to understand, to develop and maintain and extend, and also allow natural human participation. So the modular composition really enables them to quickly experiment with different ideas and create novel applications. And recently we announced a deep learning.ai course called AI Agentic Design Patterns with AutoGen. It uses a few very concrete examples to go over some very important and essential agentic design patterns, including different conversation patterns, different prompting and reasoning techniques, tool using, planning, and integration with other techniques like retrieval augmentation or other techniques. So yeah, highly recommend for starters who haven't tried AutoGen to start from that course, so you can learn all the building blocks and then build more complex workflows from there. And if you wonder about what are the use cases and what applications people are using AutoGen for, here are some survey results. The top categories include software development, agent platform, consulting, research, data processing, gaming, and simulation. And this list contains a long tail of different domains. There's a content creation, web browsing, finance, healthcare, marketing, and even there are applications for like robotics and blockchains. So yeah, very excited to see all the different applications. Here I will show you a few examples. The first one is from a venture studio called Meta Future Labs.
Yeah. Hold on. Sorry. I recognize that it wasn't very loud, so we'll get that video audio up right in. Audio. We bring up your audio settings. Where is the audio settings? Should be somewhere up there. Let's do this. We just got to make it go through that headphone for it, and that's it. Okay.
Yeah, I do a voiceover.
Yeah.
Oh, yeah.
Let's play from. Oh, sorry. Let's go back to the video and then.
Yeah.
It's the AV not working.
Yeah.
Okay.
I think I can.
Yeah, if you want to
talk it over. Yeah. Okay. That's good. So let me maybe jump into the place where we show the agent setup. Yeah. So they basically build an entire team of different agents to modeling after a real consulting team for this mature studio. And these agents will together do some market research. Starting from a very simple business idea, do the market research, do competitive analysis, and 5 or 6 different areas of research. and eventually generate a report about how valuable this idea is, how viable it is to invest. And the teams are organized in a hierarchical way so that different teams work on different areas. And within each team, there's a manager and there's multiple researchers. So the manager will iterate with multiple researchers until the quality is high enough. Here are some examples of this. The managing director talked to the chat manager to give them a task about trying to find out the product, one particular product, and the research manager will the analyst will perform that task and present some results. But often the results are not complete or not good enough. So then the manager will push back. They will put back like this to say like focusing on what you can do instead of telling me what you cannot do, things like that. And they will go back and do the work multiple rounds, and eventually they will generate complete report analysis involving all these different areas, and even generate some chart for visualization. Yes. Okay. Let's move on to the next example. That's from the Emergence AI, who use AutoGen to build some web automation tasks. So, for example, they can start from an email about a medical provider. The email talks about, okay, thanks for signing up. Here's some form you need to kind of fill up on the web. And they built an agent called Agentic that can help the users to automatically do that form fill up. You put the information and ask for users' approval to do all the filling. Yeah, so this is the user interface. Agent will say, what can I do for you? And the user will say, can you help me to kind of submit the form for me? But make me review that form before the actual submission. And then the agent will go to the right web page on the browser and start to try to find out the right information from the email, and also compare the current page. So they will find out the relevant information to fill up and start to do the job. Yeah, so users can see all the intermediate steps until it's complete, and then have a chance to review that and decide whether to approve or submit. And the caveat is sometimes this latency can be also long. It can be even longer than the human do it by themselves. But as the model improves or as you use some cheaper model, this latency can be potentially further reduced. Okay, so there are many more examples, like Agent Coin is using it for some blockchain tasks. For Web3 users and articles, they design agents of different roles to include like payments, market research and trading, social content curation, predicts, and so on. And they're like heavily relying on AutoGen to build their next generation of agents. AT&T has been using AutoGen agents for their Ask AT&T platform for like the customer service, and they are also contributing back with some enterprise features. And the last one is from a Microsoft use case from the security team. They are using AutoGen for triage, investigation, and formulating responses to security alerts and incidents. Rajiv is actually also here. Feel free to ask him more about this use case afterwards. Okay. As an overview, there have been so many enterprise customer interests from all the different vertical domains, and it's used by companies of all different sizes, organizations, or universities for many diverse applications. Some organizations use AutoGen as a backbone to build their own agent platform to support diverse applications, and others goes after many concrete agent applications. And that's a result of like having a great big community of open source. There are so many contributors. They're creating all the different doing so many activities, including building use cases, building tutorials and videos. They're so passionate, and we appreciate that. And we also got awards from like iClear in a workshop as the Best Viewer Award, and many other awards, including also press coverage. And the deep learning.ai course is very popular. It's got very high enrollments in a very short amount of time. And the entire communities are working very hard to address some hard questions like how to create the best multi-agent workflow for a particular application, how to create highly capable agents for ensuring safety, human agency, and scalability. These are several open questions that are categories we're working on. I will briefly mention a few of them. So on high level, we have these several categories. For evaluation, we are building agent-based evaluation tools or benchmarking tools. I will talk about one particular example in the next slide. And for the interface, rapidly making progress, make it even easier to program these multi-agent conversations and lower the barrier of entry. And for learning, teaching / optimization, the focus is about making the agents able to take lessons or learnings from other agents or users and make them improve over time. In the afternoon, I listened to a talk by Mike to talk about this ARC AGI benchmark. He also mentioned a very good insight that his definition of AGI is the agents that a system that can automatically acquire new skills applied to solve new applications. So this category is very important to address that perspective. And finally, the integration category is about extending the agent capabilities to integrate with different models or capabilities like multi-modality or RAG and so on. So I will briefly mention this agent eval work that's about building agents that are capable of analyzing the execution logs and automatically suggest success criteria of authentications. So you don't need to scratch your head so hard to think about how to evaluate the agent exactly. The agent will help you find out the dimensions you focus on, and also have another quantifier agent to automatically score the current performance. And for example, for solving the math problems, it will suggest, okay, we should look at how well the agent understands the problem, and is the mathematical formulation correct, is the solution reasonable, and is the calculation correct, and so on. So we'll give you 6 or 7 different criteria to assess. And then another agent will then score a different method against these criteria. So you can compare them, get the bar charts, and then understand what area you need to improve. This agent optimizer is a research to maybe that inside further to not only kind of evaluate the performance, but also let the agent to think about what needs to be improved. For example, agents we can make agents automatically look at some training data and try to suggest some tools to solve some coding-related problems, and iterate on that and find out how to modify the tools to make the solution even more efficient. So this is similar to traditional machine learning idea, except that in this case, we're just using the agents and training these agents to kind of improve without changing the model itself. But it works quite well for some coding tasks. And to further make some more advanced learning and teaching setup, you could even make one powerful agent teach some other relatively weaker agent. The powerful agent can be using some expensive models like GPT-4, and the weaker agent can use some less expensive model like GPT-5. But by combining them together, you could achieve both lower cost and higher quality for the same task compared to using such a single agent. So this is very interesting because many people have the impression that using multiple agents means that we have to pay more cost. It's actually not always the case. If you use multiple agents collaboratively and combining the models in some creative ways, you could actually achieve both higher quality and lower cost. So there are many different ways of doing this. So let me end with a quote from Jason. He in his view, he thinks there's AutoGen is the best agent framework and go-to tool for building any complex multi-agent system. And I really hope that people can join the open source community and build the future of AI agents together. So you can reach out easily on Discord and join this very large community of developers. And for recent updates, please check our recent blog posts in our website. Yeah, thank you very much.
Thank you so much, Chief. Thanks for coming down from Seattle, from the Microsoft office. We've got a few minutes left, so we always like to be super interactive. The first question here in the front.
Studio. AutoGen Studio. Yeah. AutoGen Studio. Yeah. For people who don't know about it, AutoGen Studio is a sample application built on top of the Python library. It's a web-based UI, so that you can build agents without writing code, right? So you can choose the model you want to use, the setup of the multi-agent workflow, and then as soon as you create them, you can put them in the playground and start playing with them. You can talk to these agents, inspect the input of the agents, and then expect, okay, does it work or not? And if it works, you can share with other people. So it doesn't contain all the features of AutoGen, but over time we will shape more like from the core library to the studio. But it's just mainly used as an example about what kind of like user-friendly application you could build. I've seen many other interesting UIs as well built on top of AutoGen. Yeah, thank you for the question.
Given that it's open source, there's probably creating several sequence of this concept creating a solution. You could say that some of the concept here is general.
Yeah.
And so I wonder, is that type of model you know, how are you getting oriented on?
Yeah, so this is a very important reason why having a modular framework can help developers to really experiment with many different ideas quickly and keep making progress. So, for example, if you find a few agents working very good to solve certain parts of the problem, you could keep that setup and or just create a single agent that wrap those several agents as a reusable agent. So in the future, if your system contains a bigger scope, you don't have to remove your existing work. You can just build more agents that does other work but reuse the existing functionality, right? Or if you find certain parts doesn't work, you could do unit testing for that particular agent and keep improving on that. And after it works, you keep that part and keep on innovating. So to get to a really accuracy for, especially for like the accuracy sensitive applications like healthcare or finance, this is highly, highly important. I do see some success in those regulating sectors, which is quite encouraging. Yeah. Thank you.
The last question for thank you for the so following up on that, it's very high level simplification, but then you have a really complex system, you can get powerful innovation and it's fire of control and direction. What's your thoughts on this controlling this kind of noise?
Yeah, this is a very, very important question, very good question. So what I've seen in practice, people do unit testing for each simple agent, so make sure each of them function very well. And then you can write more and more complex tests that cover maybe a bigger scope of the system. The simple unit tests are really easier to write if you keep the agent functionality simple, as simple as possible. So break down complex tasks into relatively simple parts. So that generally increase the success for each simple step. But still, you probably need some more complex tests that cover the end-to-end performance. And you can use agents. You can build some agents that specifically good at evaluation or optimization to help you also automatically do some of these jobs. So that's like the hint I mentioned for the agent eval and the agent optimizer work. I think those are along that line. And another thought about that is, okay, so by adding more component system, so it can increase error, but there's also ways to build some redundancies to actually decrease error by using more agents. So, but there's a trade-off between like the cost and quality, because when you use, for example, make multiple agents perform the same task and some of them fail, some succeed, you do increase the overall success of the system, but also that will bring no cost. But the idea of, like I mentioned, in the ecosystem, by combining the agents of different capabilities. So, for example, you can use different models or even the same model with different configurations. We have found that worked very well last year on the human eval coding tasks. We can improve the performance accuracy from like 67% to 90%, while the cost is actually reduced instead of increased. But you just need to figure out the best configuration, best setup to achieve that effect. But this is, I think, that's the huge design space provided by the multi-agents. You can choose to like spend more cost or to increase like the success, or like try to cleverly combine agents to reduce the cost, or keeping the same success rate. So there's huge design space to explore.